looking at the last two shapes, the area of the last two shapes, circles and sectors. So a circle, we can yet again express as the radius there, and this is our diameter here. And we need to find the area of the circle. Now you remember in the previous lesson we looked at the circumference of the circle, which was 2 pi r. In this case, the area is going to be equal to pi r squared. So please put that in your notes. The last one we're going to have a look at is the sector. Now I'd like to introduce the sector in this manner. We can say here, here, and also this one here. So let's look at the fraction of these of a circle. So this one here is a pretty typical shape. It's called a semicircle. And we know it's half a circle, right? Because it's a semicircle. Therefore, it stands to reason that the area of this is half of the area of a circle. So half pi r squared, where this part comes from the area of a circle. Now, the shape next to it is a quarter of a circle. So it stands to reason that the area of this shape is a quarter pi r squared. The last one's more unusual. Let's say, for instance, it is, let's call that 320. So this sector goes on for 320 degrees. So in this case here, how much of a circle is it? Well, let's look back to our previous examples. What was the angle here? 180 degrees. What was the angle here? 90 degrees. Now let's think of this as a fraction of a circle. 180 out of 360 is indeed a half. This one, 90 out of 360, is indeed a quarter, and this last one would therefore have to be 320 out of 360. So all of these terms here, the coefficients, the half and the quarter, are just simply a fraction of 360, but it's been simplified. So what's the area of this sector over here? Well, this is where we can introduce our formula and also what the answer would be. So the area is going to be 320 degrees on 360, the fraction of the circle, times by pi r squared, which brings us to our formula. A is equal to theta 360 times by, pi r squared. Please copy these down into your notes.